Okay, so part one of the assignment asks you to manually generate polynomial functions to model the path of the ball as it leaves the shooter's hand until it touches the hoop. So I've currently got the data for when it left my hand, creates the shape of the parabola, and then it touched the hoop here. Now we need to have the R² score to be better than 90. In the other videos, you should have already generated your manual line of best fit for it using the coordinates. Now, it doesn't matter whether you choose turning point form or whether you choose to use ax² plus bx plus c. We just need one manually generated polynomial function. So once you've got that, pop it into Desmos. Now, this is the one that I generated. You can see here that my R² score is 0.8055. So that currently doesn't meet our restrictions. If this looks normal, it doesn't look like there's a problem, then you're going to have to do it again with different coordinates and try and create a better function, because your task is to get better than 0.9, which means that anything less and you won't have hit the top sections for solve. So if I turn this function on, you can see that it's fitting these first three coordinates nicely, but then over here, it's not following the shape of the parabola. That would indicate, because I've used this point, and this point, that would indicate that I've had a mistake somewhere. So I need to go back and try again and fix my algebra. Now, you're going to need to do that on your own if you make a mistake, because it's really hard for us to find your errors. A lot of the time, it's easier to just start from scratch. So that's how I'm testing my manually generated one. I might also choose to include one of Desmos, one that it recommends to us, just to be able to compare my A, my B, my C values, and to be able to see what the best possible R² score would be for my function. Okay, once you've done that, you're ready to start digitally generating polynomial functions for the path of the rest of the ball's journey.